Let's talk about the hidden rules of math. You know, this system that keeps everything from falling into total chaos and makes sure we all get the same answer to the same problem. This is all about the order of operations. So, to really get why this is so important, let's start with what looks like a super simple math problem. It's the kind of thing you see blow up on social media, right? Sparking a huge debate with thousands of people arguing over the one right answer.
All right, take a look at this. 48 divided by 8 minus 4. What's your first instinct? Do you just start on the left and work your way across, or do you do the subtraction first? Well, depending on what you choose, you're going to get one of two very different results.
And here's that confusion in action. If you decide to subtract first, you get 12. But if you divide first, you get 2. I mean, those answers aren't even close. So which one is correct? This right here is exactly why we need a shared system. For math to be this universal language for science, for engineering, for, well, everything, we just can't have this kind of confusion. We need one single correct answer every single time. We need a rule book. And thankfully, we've got one. It's called the order of operations, and it's the system that mathematicians all around the world have agreed on to bring certainty and clarity to all their work. I absolutely love this analogy. Think about it. Just like grammar tells you where to put commas and periods to make a sentence make sense, the order of operations tells you what to do first to make an equation make sense.
So, the key takeaway here is that it's a hierarchy. It's a set of steps you follow in a very specific sequence, from most important to least important, that guarantees you and anyone else looking at the same problem will end up at the exact same solution.
So, what is this secret code? Well, you've probably heard of it before. In the US, it's most commonly known by the acronym PEMDAS. Let's break down what that actually stands for. Here it is, the whole shebang. First up, you have to handle anything inside parentheses or other grouping symbols like brackets. Next, you tackle the exponents. After that, and this is super important, comes multiplication and division. They're on the same level of importance. And finally, you have addition and subtraction, who are also partners on the same level. Now, this is the part that trips almost everyone up. PEMDAS does not mean multiplication always comes before division. They're a team. You solve them as you see them, just moving from left to right across the equation. The exact same rule applies to addition and subtraction.
All right, theory's great and all, but let's actually see how this rulebook works in the real world. We'll start with a nice, clean example to see that first rule in action.
Okay, here we go. 15 times the quantity of 2 plus 1. Now, without our rules, you might just be tempted to multiply 15 by 2 first. But with PEMDAS, our path is totally clear. The P in PEMDAS is our guide. It's screaming, hey, go straight for what's inside the parentheses. So 2 plus 1 becomes 3, and look at that, the problem already got way simpler. And now we're just left with one simple operation, 15 times 3. The final and only correct answer is 45. See, it's clean, simple, and there's no confusion. Okay, that was a good warm-up. Let's level up to a more complex problem and see how these rules start to stack. This next one brings in different grouping symbols and, you guessed it, that's second level of our hierarchy, exponents. Whoa, check this out! 12 times the stuff in the brackets, 5 squared minus 4 squared. Don't let those square brackets intimidate you. They function just like parentheses. They're basically just a big sign saying, deal with everything inside of me first. So we look inside the brackets, and what do we see? We've got exponents and we've got subtraction. Well, according to PEMDAS, E for exponents comes way before S for subtraction. So 5 squared becomes 25, and 4 squared becomes 16. Perfect. Now we can finally resolve what's left inside those brackets. 25 minus 16 is, of course, 9. Look how what seemed like a complicated expression is just getting simpler and simpler with every step. And for our last move, we just have 12 times 9, which gives us our final answer, 108. By following the rules step by step, we took a complex problem and broke it down into easy, manageable little pieces. Oh, and here's a pro tip, a place where the rules provide some hidden clarity. Fraction bars. You should think of them as sneaky grouping symbols. The rule is simple. Solve the entire top part first, then solve the entire bottom part, and only then do you divide. It's like there are invisible parentheses around the numerator and the denominator. So why does any of this matter outside of a math class? Well, because these rules are actually what allow us to translate real-world problems into a mathematical language that works. Let's take a simple word problem.
We're buying some cookies. We've got 2 of one kind, 3 of another, and they all have the same price. How do we figure out the total cost?
This is where the order of operations becomes a tool for clarity. We need to find the total number of cookies first. So we group 2 plus 3 in parentheses. That gives us 5 total cookies. Then we multiply by the cost, 8 cents, to get our answer, 40 cents. Without those parentheses, we'd get the wrong answer every single time.
So you see, the order of operations isn't just some random set of rules. It's a system for creating clarity and a shared understanding. It turns potential chaos into predictable logic, which kind of leaves us with a final thought. Think about a recipe, or the rules of a game, or even a piece of sheet music. Where else do you rely on a specific order of operations to make sense of the world?